practice of dyeing Romex wiring is a serious safety concern and a blatant violation of electrical codes and standards. There are code violations present in the scenario that was described. National Electrical Code Article 800.13 states that conductors of different systems of circuit shall not be contained within the same raceway, cable, or enclosure. National Electrical Code Article 402.1 states that the marking of conductor insulation shall conform to the requirements of Article 310. There are safety hazards present as well. Firstly, confusion can arise. Yellow and orange wires are typically associated with different circuits, for example kitchen, bathrooms, water heater and dryer respectively. This tampering could lead to misidentification and electrical accidents. Secondly, overload can occur. Combining multiple circuits on a single wire could exceed the wire's capacity, leading to overheating and fire. Thirdly, a shock hazard can be created. Damaged or exposed colored wire could create a shock hazard. Inspectors play a crucial role in ensuring electrical safety. They must carefully examine electrical systems and report any violations. In this case, the inspector should have failed the inspection and required the contractor to remove the dyed wiring. Tampering with electrical wiring can result in failed inspections, electrical hazards, property damage, personal injury, or death. It is imperative that electrical contractors follow proper codes and standards. Inspectors must remain vigilant in detecting these types of violations and holding accountable those who compromise electrical safety. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. It's updated regularly to address new technologies and safety concerns. It's important for electricians, inspectors, and anyone working with electrical systems to be familiar with the NEC. Article 310, mentioned earlier, deals with conductors for general wiring. It specifies requirements for conductor insulation, opacity, and other characteristics. The NEC provides tables that list the allowable opacities for different wire sizes and insulation types. These tables take into account factors such as ambient temperature and the number of conductors in a raceway. It's crucial to select the correct wire size for a given circuit to prevent overheating and fire hazards. Overloading a circuit can cause the insulation on the wires to melt, leading to short circuits and fires. Grounding is another important aspect of electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and to energize the circuit. Grounding also helps to protect people from electric shock by providing a path for current to flow to ground in the event of a fault. Ground fault circuit interrupters, or GFCIs, are another important safety device. GFCIs are designed to detect small amounts of current leakage to ground and trip the circuit, preventing electric shock. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or SIs, are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults can occur when there is a break in the insulation of a wire, or when there is a loose connection. SIs detect the characteristics of arc faults and trip the circuit, preventing a fire. Electrical panels should be properly labeled to identify the circuits that they control. This helps to prevent confusion and makes it easier to troubleshoot electrical problems. The electrical panel should also be kept clear of obstructions so that they can be easily accessed in an emergency. Extension cords should be used with caution. They should not be used as a substitute for permanent wiring. Extension cords should be properly sized for the load that they are carrying, and they should not be overloaded. Damaged extension cords should be replaced immediately. Light fixtures should be properly installed and maintained. Bulbs should be the correct wattage for the fixture, and they should be replaced when they burn out. Damaged light fixtures should be repaired or replaced. Electrical appliances should be used according to the manufacturer's instructions. Appliances should be properly grounded, and they should not be used near water. Damaged appliances should be repaired or replaced. Working with electricity can be dangerous. It's important to take precautions to protect yourself from electric shock. Always turn off the power before working on electrical circuits. Use insulated tools and wear rubber gloves and safety glasses. If you're not comfortable working with electricity, hire a qualified electrician. Regular electrical inspections can help to identify potential safety hazards and prevent electrical problems. Electrical inspections should be performed by a qualified electrician or electrical inspector. The National Fire Protection Association, or NFPA, is a non-profit organization that develops codes and standards for fire safety. The NFPA publishes the National Electrical Code, as well as other codes and standards related to electrical safety. Underwriters Laboratories, or ALL, is a company that tests and certifies products for safety. UL-listed products have been tested and found to meet UL safety standards. The International Association of Electrical Inspectors, or IE, is a professional organization for electrical inspectors. The IE provides training and certification for electrical inspectors. Continuing education is important for electricians and electrical inspectors. The electrical industry is constantly changing, with new technologies and safety standards being developed all the time. Continuing education helps electricians and electrical inspectors to stay up to date on the latest developments in the industry. Tampering with electrical wiring is not only a safety hazard, but it's also illegal. People who tamper with electrical wiring can be fined or even jailed. Electrical contractors who violate electrical codes can lose their licenses. It's important to report any suspected electrical code violations to the local authorities. Electrical safety is everyone's responsibility. By following proper codes and standards, and by being aware of potential hazards, we can help to prevent electrical accidents and save lives. Let's delve deeper into the specific dangers associated with dyeing Romex wiring. The primary concern is the alteration of the wire's insulation. The insulation is carefully designed and manufactured to meet specific standards for voltage rating, temperature resistance, and flame retardancy. Dyeing the insulation can compromise these properties in several ways. The dye itself may contain chemicals that degrade the insulation material over time. This can lead to cracking, brittleness, and a reduction in the insulation's ability to withstand voltage. The dyeing process can also introduce moisture into the insulation, which can accelerate the degradation process and increase the risk of electrical leakage. Furthermore, the dye can change the color coding of the wires, making it difficult to identify the different conductors in a circuit. This can create confusion for electricians and homeowners, and it can increase the risk of accidental shocks or short circuits. The practice of using different colors to identify different circuits, as mentioned earlier, is a standard safety practice. For example, in many residential wiring systems, black wires are used for hot conductors, white wires are used for neutral conductors, and green or bare wires are used for grounding conductors. This color coding helps to ensure that circuits are wired correctly and that electrical problems can be diagnosed and repaired safely. When the color coding is altered, it can become difficult to trace circuits and identify potential hazards. This can be especially dangerous in older homes where the wiring may not be up to current standards. The NEC requires that electrical wiring be installed in a neat and workmanlike manner. This means that the wiring should be properly supported, protected from physical damage, and labeled to identify the circuits that it serves. Dyeing Romex wiring is a clear violation of this requirement, as it creates a messy and unprofessional appearance. It also makes it difficult to inspect the wiring and identify potential problems. Electrical inspectors have a responsibility to enforce the NEC and to ensure that electrical installations are safe. When an inspector finds that Romex wiring has been dyed, they should immediately reject the installation and require the contractor to remove the dyed wiring. The inspector should also report the violation to the local authorities, who may take further action against the contractor. Homeowners should also be aware of the dangers of dyed Romex wiring. If you suspect that your home's wiring has been tampered with, you should contact a qualified electrician to inspect the wiring and make any necessary repairs. Do not attempt to repair the wiring yourself, as this can be dangerous. It's also important to be aware of the signs of electrical problems, such as flickering lights, tripping circuit breakers, and burning smells. If you notice any of these signs, you should contact a qualified electrician immediately. Electrical safety is a shared responsibility. By following proper codes and standards, and by being aware of potential hazards, we can help to prevent electrical accidents and save lives. Now let's discuss the specific code violations in more detail. NEC Article 800.14, which prohibits conductors of different systems or circuits from being contained within the same raceway, cable, or enclosure, is designed to prevent interference and crosstalk between different electrical systems. For example, if a power circuit and a communications circuit are run in the same conduit, the power circuit can induce noise into the communications circuit, which can degrade the quality of the signal. This is especially important in sensitive electronic equipment, such as computers and medical devices. NEC Article 402.1, which requires that the marking of conductor insulation conform to the requirements of Article 310, is designed to ensure that electrical wiring is properly identified and that it meets the safety standards of the NEC. Article 310 specifies the types of insulation that are permitted for different applications, as well as the marking requirements for conductors. The marking requirements include the wire size, the insulation type, the voltage rating, and the manufacturer's name or trademark. These markings are essential for identifying the conductors and ensuring that they are used in the correct application. In addition to the code violations, the practice of dyeing Romex wiring can also create a number of practical problems. For example, the dye can make it difficult to strip the insulation from the wires, which can slow down the wiring process and increase the risk of damaging the conductors. The dye can also make it difficult to make good electrical connections, which can lead to loose connections and overheating. Furthermore, the dye can attract dust and dirt, which can further degrade the insulation and increase the risk of electrical problems. The cost of dyeing Romex wiring can also be significant. The dye itself can be expensive, and the dyeing process can be time-consuming. In addition, the contractor may have to pay for the cost of removing and replacing the dyed wiring if it is rejected by the electrical inspector. In the end, the practice of dyeing Romex wiring is simply not worth the risk. It is a safety hazard, a code violation, and a practical problem. Electrical contractors should always follow proper codes and standards and avoid any practices that could compromise electrical safety. The consequences of tampering with electrical wiring can be severe, ranging from property damage and personal injury to death. Electrical fires are a leading cause of property damage in the United States, and many of these fires are caused by faulty wiring. Electric shock can also be fatal, and it can cause serious injuries, such as burns, nerve damage, and cardiac arrest. It's crucial to remember that electricity is a powerful force, and it should be treated with respect. Never attempt to work on electrical wiring unless you are a qualified electrician. If you have any doubts about the safety of your home's electrical system, contact a qualified electrician to inspect the wiring and make any necessary repairs. Let's explore the impact of improper wiring on electrical systems, focusing on overload and shock hazards. Overload occurs when a circuit is subjected to a current higher than its rated capacity. This excess current generates heat in the wires, potentially melting the insulation and causing a fire. The National Electrical Code specifies the maximum allowable ampacity for different wire sizes and insulation types. For instance, a 14 American wire gauge or copper wire with type THHN insulation is typically rated for 15 amps. While a 12 AWG copper wire with the same insulation is rated for 20 amps. Exceeding these limits can lead to dangerous overheating. The use of undersized wiring is a common cause of overload. For example, if a homeowner replaces a light fixture with a more powerful one without upgrading the wiring, the circuit may become overloaded. Another cause of overload is plugging too many appliances into a single circuit. This is often seen with the use of power strips and extension cords. While these devices can be convenient, they can also create a fire hazard if they are overloaded. Shock hazards arise when a person comes into contact with an energized electrical conductor. The severity of the shock depends on several factors, including the voltage, the current, and the duration of the contact. Even a small amount of current can be dangerous, especially if it passes through the heart. Ground fault circuit interrupters, or GFCIs, are designed to protect against shock hazards. These devices monitor the current flowing in a circuit and quickly trip the circuit breaker if they detect a ground fault. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Another important safety device is the arc fault circuit interrupter, or SI. SIs are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when there is an unintended electrical discharge between two conductors. This can happen when there is a break in the insulation of a wire, or when there is a loose connection. SIs detect the characteristics of arc faults and trip the circuit breaker, preventing a fire. Proper grounding is also essential for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and energize the circuit. Grounding also helps to protect people from electric shock by providing a path for current to flow to ground in the event of a fault. Electrical panels should be properly labeled to identify the circuits that they control. This helps to prevent confusion and makes it easier to troubleshoot electrical problems. The electrical panels should also be kept clear of obstructions so that they can be easily accessed in an emergency. Regular electrical inspections can help to identify potential safety hazards and prevent electrical problems. Electrical inspections should be performed by a qualified electrician or electrical inspector. Tampering with electrical wiring is a serious crime that can have devastating consequences. It's important to follow proper codes and standards and to be aware of the potential hazards associated with electricity. By working together, we can help to prevent electrical accidents and save lives.